formula we had earlier used, Q is equal to mc delta T. Now here we are going to use another formula, m into L. Okay, whenever there is a change in state, we use this formula, m into L. Rest other formulas are same as we have done it earlier, like heat capacity is m into small c. So certain standard things are like for water it is 4.2 joule per gram per Kelvin, and this is for water. For ice it is 2.1 joule per gram per Kelvin. Okay, that is for ice. And the latent heat for ice and water, it is 336 joule per gram, which is again multiplied by 1000 for joule per kg. Okay, now remember the values need to be given in the numerical. You can't just assume them. It has to be provided in an exam. Okay. Before moving to the numericals, I'll give you a situation which we will try and get an answer to. Say for example, you have 50 grams of water, okay, which is at say 15 degrees Celsius, and you have to turn it into ice, okay, which is at -5 degrees Celsius. So that's the situation. I want you to understand that in this particular process, there will be 3 steps. So step number 1 is water, which is at 15 degree, will turn into water at 0 degree. The second step is water, which is at 0 degree, turn into ice at 0 degree. And the third step is ice at 0 degree will become ice at -5 degree. These are the 3 steps. Okay, is there any confusion in this?
No, sir.
Now, how much will be this heat? So that will be mc delta T. So that is 50 into 4.2 into 15 minus 0, because from 15 degree you're bringing it to 0 degree. So this value will be equal to you will have 50 into 4.2 into 15. So that will be 3150 joules. In this case, here this is m into L, that is 50 multiplied by 336. So 50 into 336, that will be 16800 joules. And then again there is a change in temperature, so that is mc delta T, 50 into 2.1 into 5. Okay, like I told you in the previous class, that you don't consider that as negative. Okay, the change in temperature to be represented as positive. So this is 525 joules. So the total energy is 3150 plus 1680, and then you will have 525. So that will be 5355 joules. So 50 grams of water from 15 degree is brought to -5 degree. The amount of heat that will be lost by the water will be this much. Okay, and there are appliances like a refrigerator which helps us to do that, to take away heat from a substance. So as you must have noticed, compared to what we have done in a previous exercise, we will continue to do the same. Okay, only thing is we have to be mindful about whether there is a change of state happening, and whenever there is a change of state, we use this formula ml instead of mc delta T. Okay, so I would like you to read the first question. okay, in your mind, and understand the process, what is happening. So we have 10 grams of ice, which is at 0 degree, and it absorbs 5,460 degree joules, 5,460 joules, and it becomes water at 50 degrees. So it's like a kind of a reverse process of what I've told you. So mass is 10 grams, okay, and the temperature is 0 degree, and it is ice, and the final temperature, okay, is 50 degrees Celsius, water. Okay, and the total heat, okay, total heat in this case is 5460 joules. They have also given us specific heat capacity as 4200 joule per kg per Kelvin. What they ask us to calculate is latent heat. Okay, so I'm writing this as a single equation. So when you have 0 degree ice, if it has to melt, it has to take the heat equal to m into L. Now 0 degree water to 50 degree of water is mc delta T. So this is 5460, that is 10 into L plus 10 into 4.2. Now from 0 degree water to 50 degree water, so therefore delta T is 50. Please tell me if you have not understood this expression. Is it clear to everyone?
Yes, sir.
Okay, so here we leave aside, like you can take out 10 common. This is a plus sign, so that's like a, you know, it's a math linear equation for you. So this is 546. This is L plus, it will be 4.2 multiplied by 50 is 210. So L will be 546 minus 210. So 546 minus that will give us 336 joules. Okay, so that's joule per kg gram. This is joule per gram. Okay, remember writing proper units. Right. So that's why I
So
told
can
you,
you
like,
just explain once again why do we take ml plus mc delta t?
because the first thing that we have is 10 grams of ice at 0 degree Celsius. This will give us 10 grams of water at 0 degree Celsius. So for that we need m into L, and then it will take 10 gram of water at 50 degrees Celsius. For that you will need mc delta T. Is that
Okay, sir. Yes, sir.
so? So that process should be clear. Okay. The next what we will do is question number 2. Okay, I'll scroll this. Okay,
So can you
so
just go up, please?
yeah. How much heat energy is released when 5 grams of water? So mass is equal to 5 gram, okay, which is at 20 degrees Celsius. So T1 is 20 degrees Celsius. It is turning into ice at 0 degrees Celsius. So this is also provided 4.2 joule per gram per Kelvin, and latent heat is 336 joule per gram. Right.
So
Now,
whenever they give us such questions, we will always have to take ml plus mc delta t, right?
right. Yeah. So this also is now clear that 20-degree water first has to become 0-degree water, that is mc delta t.
Yes, sir.
And then water has to freeze. So that is m into L. So that is 5 into 4.2 into 20. And this is 5 into 336. So you can make your calculation easier. 4.2 into 20. Okay, so this will become 4.2 into 20, that is 84 plus 336. So that will be 5 into 420. So that will be 2100 joule. Okay, then we move to number 3. Molten metal of mass 150 grams. So mass is given to be 150 gram, and it is at 800 degrees Celsius. So T1 is 800 degrees Celsius, and remember this is liquid. Okay, now it is allowed, and this is the melting point as well. So this is 800 gram is also the melting point, and then it is allowed to freeze at the same temperature. So T2 is also 800 degree, and it is becoming solid. So therefore it is very clear that Q is equal to M into L. Okay, Q is equal to M into L. There is no MC delta T because there is no change in temperature. So this is 75,000, and this is 150 gram into L. So 75,000, and this is 150. So you know 15 fives are, so that will be 500. Okay, so, and this is given in grams, and therefore I can say L will be 500 joule per gram will be the latent heat. So no one should have any confusion because it's clearly written that 800 degrees Celsius is the melting point, and the metal was in a molten state, and it is freezing. So that is, it is becoming 800 degrees Celsius molten metal to 800 degrees Celsius frozen metal. So that means there is a change of state that happens. Okay, so this is A. Now in B, what you have, the specific heat capacity of the metal is given, that is 200 degrees Celsius. Now, just a minute. So 200 degree is the specific heat capacity of the metal, and the temperature drops from 800 to -50. Okay, so what is the change in temperature? Can you tell me that? How much is the change in temperature? If 800 degree to -50 degree, what will be the change in temperature?
850 degrees.
Very good. Okay, it is 850 degree is the change in temperature. See this, if you look at the scale, this is 0 degrees Celsius, this is 100, this is 200, this is 800, and this is -50. So when you're going from here to here, okay, so this is 850. Okay, and we know the mass is 150 grams. So Q is equal to MC delta T, that is 150 into 200 into 850. So this will indeed be a big number. And that comes out to be, okay, there's one thing that we need to take care of. This is kilograms and we are substituting grams. So if you divide by 1000, we can reduce 3 zeros in this. So this will give us 25500 joules. Okay, any question in this? So after this, we'll do
No,
number.
sir.
A refrigerator converts 100 grams of water. So therefore, this is 100 gram. This is 20 degrees Celsius. Okay, and it will go till negative 10 degrees Celsius. Okay, and the time is 73.5 minutes. So that will be 73.5 into 60. And this will be 4410 seconds. Okay, we have to find the watt, how much is the power. So we have seen that Q is equal to MC delta T, and we have Q as P into T. So the total energy will be power. Okay, power into time. But if you recount the process, there are three steps. 20-degree water to 0-degree water, 0-degree water to 0-degree ice, and 0-degree ice to minus 10-degree ice. And this process will be MC delta T, that is number 1, plus M into L, that is number 2, plus MC delta T, that is number 3. Okay, so let us substitute. This is P into 4410. This is 100 into 4.2 into 20. This is 100 into 336. Okay, plus 100 into 2.1 into 10. So this 10 is delta T, 0 degree to negative 10 degree. So I can take the 100 out. I can make this 4.2 into 20. This is 336.
Sir, we're only taking ml for second one because of the specific latent rate, right?
Yeah, this is the change of state, water to ice. So P will be equal to 100 into, this will be 84 plus 336 plus 21, 4410. Okay, so what we have is 84 plus 336 plus 21. This will get cancelled and power will be 10 watt. Okay, so again, this question will be for, if it is for 3 marks, the marking is done like this. If you get this or this correct, you get 1 mark. To equate them, you get 1 mark, and 1 mark for the final answer. If it is for 4 marks, then you get 1 mark, 1 mark. For equating them, you get 1 mark, and then 1 mark for the final answer. So what you have in this is 10 grams of water which is at 10 degrees Celsius. Okay, and then you have 10 gram of ice, which is at negative 10 degrees Celsius. Okay. Now the process of, the way we approach this question, knowing that the final state is where everybody is at the same temperature. That's the final state. Okay. Everyone will be at same temperature. So the first step that I'm going to do over here is calculate the amount of heat that 10 gram of water will lose to come from 10 degrees Celsius to 0 degrees Celsius. Okay. So amount of heat lost by 10 grams of water to come from 10 degrees Celsius to 0 degrees Celsius will be equal to, okay, MC delta T, and that is equal to 10 into 4.2 into 10, that is 420 joules. Is that clear to everyone? So if 10 grams of water is there, that 10 gram of water,
So your screen stopped sharing.
yeah, that 10 gram of water will lose 420 joules, okay, and it will become 0 degree water. Are you following that? So remember this, we had 10 gram water at 10 degrees Celsius. We had, just a minute, I'll write it neatly because I'll be referring to this. We had 10 gram of water at 10 degrees Celsius. I had 10 gram of ice at minus 10 degrees Celsius. Now what do I have? I have 10 gram of water at 0 degrees Celsius plus 420 joules, and I have 10 gram of ice at minus 10. So far, any questions?
No, sir.
No, sir.
Now this 420 joules will be taken by 10 gram of ice. So remember this. Okay. So what we have over here is 420 joules.
So the 10 gram of ice will take 420 joules to become
No,
like
that,
ice at 0 degrees Celsius, right?
what will it become? We'll check. Okay, whether it will be able to become, okay.
Okay, sir.
420 joules will be taken by 10 gram of ice, which is at negative 10 degrees Celsius. Okay. So this is at negative 10 degree Celsius. Okay. Now what will happen in this? So as you said, obviously, the first step in this will be to take ice from minus 10 degrees Celsius to 0 degrees Celsius. Are you following that? How much heat will be required? If you want to take ice from minus 10 to 0 degree, the heat will be required will be MC delta T. That will be 10 into 2.1 into 10. That will be 210 joules. Any questions in this?
No.
How much heat is left now? 420 minus 210, that is equal to 210.
210.
Okay, so we'll see what is there with us. We have water at 0 degree. We have 10 gram of ice also at 0 degree. And we have 210 joules. Okay, like I told you, the final temperature, final situation is where we have everything at the same temperature. But we have water at 0 degree, ice at 0 degree, but this is extra. 210 joule is more. What do you think this 210 joule will be used for?
Converting ice to water.
Very good. Okay, so let's write that down here. This heat will be used to convert ice to water. Okay, now how much we know that Q is equal to ml. Q is equal to ml. So therefore 210 is m into 336. So m will be 210 upon 336. Now this calculation, if you do 3 sevens are 112, you get it as 0.625 grams. Okay, that means 210 joule can melt 0.625 grams of ice. Okay, so therefore, what is your answer? You have 10 gram of water at 0 degrees Celsius. You have now over here 10 minus 0.625 equal to 909.375 grams of ice at 0 degrees Celsius and 0.625 gram of water at 0 degrees Celsius, because that much of ice got melted. Okay, do you follow this?
Yes, sir. But sir, they were asking for the specific latent heat.
No, that's not the question. They are asking what will.
Oh yes, sir. Yes, sir.
So what you can say that 10.625 gram of water will be at 0 degrees Celsius, and you will have 9.375 grams of ice at 0 degrees Celsius. So that will be your final answer. I mean, that much of things will be left in the mixture. Right. Any questions, anyone?
No, sir.
Now you have a piece of ice that is added at 40 grams of 200 grams of water. Okay, now this is like, we will write it like a table. So this is ice, this is water. So mass of ice is 40 grams. Mass of water is 200 grams. Here the temperature of ice is 0 degree. Temperature of water is 50 degrees Celsius. And we have to find the final temperature. So delta T is T minus 0, which is equal to T. And this is 50 minus T. Okay, rest other things is specific heat capacity is 4.2 joule per gram per Kelvin, and latent heat is 336 joule per gram, right? We write down the statement that we had written earlier, that if no heat is lost to the surrounding, then heat lost by hot body is
Is
equal to
the heat gained by the cold body?
cold body, right? So that statement we will write. Okay, now in this particular question, the hot body is water. So heat lost by hot body is M1, C1, delta T1. And heat gained by cold body is ice. Now, what is ice doing? First, it is melting, and then the temperature will rise. So this you need to understand, okay? Because see, it's if you put the values in the correct formula, that is a simple algebra to get to the answer. The physics is understanding this, okay? So in this particular case, 200 grams of water, this is 4.2, and this is 50 minus T. So that is 40 into 336, and this is 40 into 4.2 into T. Okay, that is just T because the initial temperature is
So can you
0.
repeat why do we take ml?
Because you only think you are adding ice to water. So what is going to happen? Suppose the final temperature is 10 degrees Celsius. Okay, that means you have water in it. This water is 50 degrees Celsius, and you are adding ice to it. And after adding ice, what will happen? Everything will turn into water, and
Yes, sir.
the final temperature is 10 degree. So 50 degree water has become 10 degree. What happens to the ice?
Okay, okay. So the change of state.
So first it will change to water at 0 degree, and then it become water at 10 degree. No?
Yes, sir.
Okay. To make the calculation easier, you can take 40 out. So this is 336 plus 4.2 T, and this is 200, 4.2, 50 minus T. So this can cancel 200. So that will be 5. So 5 into 4.2 will give you 21. Okay, so what you have is 21 into 50. That will be 1050 minus 21T. 336 plus 4.2 T. Now 1050 minus 336, and this is 21 T plus 4.2 T. This is 714, and this is 25.2. Okay, sometimes these numbers can be tricky calculation. So as far as possible, try to do by yourself whenever you are practicing, and not relying on calculators. Right.